Hello students, my name is Monica. We are doing class 8 Ganita Prakash chapter 1 square and a cube and going to start with the first figure it out of this chapter. Before I'll start this figure it out, I want you to note few things to remember. Things to remember. The very first thing that you must know is, as you know, the sequence of square number is 1, 4, 9, 16, 25, and so on, right? And you can write it as 1 square, 2 square, 3 square, 4 square, and 5 square, and so on, right? So the thing that you need to remember is the numbers that are ending with, the numbers that are ending with 2, 3, 7, and 8 cannot perfect square. All those numbers that are ending with 2, 3, 7, and 8 cannot a perfect square, and it doesn't mean the numbers those who are ending with 0, 1, 4, 5, 6, and 9 are perfect squares. They may or may not a perfect square. Why I am saying this to you? Let's take an example for this. 16 or 36, both are ending with 6, right? And yes, 16 can be written as 4 into 4, which is a perfect square. 36 can be written as 6 into 6, which is again a perfect square, right? But tell me one thing, what about 26? Can you write 26 as a product of two same numbers? No, right? So 26 cannot be a perfect square. You're getting that? That's why I have used the word may or may not. Must note this. Right? Second thing that you need to remember is, in this chapter, in this figure it out firstly, we will use LCM method to find out, to figure out, we will use LCM method, figure out the given number is a perfect square or not, right? So let's take an example of 64. I need to find out 64 a perfect square or not, right? I will use the LCM method for this. 64, know how to find out the LCM of 64. I'm doing it quickly. So 64 can be written as 2 into 2 into 2. LCM method. 64, all the prime factorization, the terms in the prime factorization, all are existing in pairs. Now this is a game changer, right? When you are having prime factorization in pairs of same numbers, then you can say it, this is a perfect square. This is a perfect square. Okay? So by LCM method, we can find out the given number is perfect square or not. When, like say, any number is left out, like 1331. The prime factorization of this is 11 into 11 into 11, right? We have only one pair. What about this? This is left, right? So this is not a perfect square. That's all. You must know this. Right? Now the third, figure it out. The third a thing to remember is, when you need to find out the difference between the square of two consecutive numbers. Two consecutives. Well, like I'm taking in general n square and n plus 1 square. These are the two consecutive numbers, and I need to find out the numbers lying between these two, right? N square and n plus 1 square. So they are 2n in numbers. This is the trick. You need to remember this. They are 2n in numbers. Fine. And lastly, I need to share that the concept of under root. Concept of under root. Under root can be named as square root. So what is this? In general, I'm taking it in general. In general, if y is equals to x square, then x is square root of, that means x can be written as under root of y, square root of y. So this is the radical sign of under root. Right? Radical sign means how we symbolize it. Okay, so this is the radical sign of under root. Hope this is clear to you. And now we are going to start with the figure it out. Question number 1. Which of the following numbers are not perfect square? So part 1 here, that is 2032. See, in the first thing to remember, I have discussed that when the number is ending with 2, 3, 7 and 8, they cannot be a perfect square. So it is ending with 2. The number is ending with 2. Number is ending with 2. So it cannot be a perfect square. Right? This way you need to present your answer. Now part 2, 2048. 2048, again the number is ending with 8. So again this is not a perfect square. Third, 1027. The number is ending with 7. So again the answer will be no. Lastly, 1089. 1089. The number is ending with 9. Now this is a game changer. You are not getting anything from 2, 3, 7 and 8. This is from the second pair, 0, 1, 4, 5, 6 and 9. Right? So the number is ending with 9. So I've told you earlier that it may or may not a perfect square. Yeah, may and may not a perfect square. And how to figure out that it is a perfect square or not? Let's move to the that we will figure it out in the coming questions. Okay. So question number now. Question number 2. Which among these has last digit 4? See, for this you don't need to solve wholly. You have 64 square. Okay? 64 square, there is no need to find 64 into 64 and do all the multiplication. No. See here, the unit digit of 64 is 4, right? So 4 into 4 gives you 16 and its last digit of 16 is 6. So which is not leading us to the answer. Okay. So now let's check for 108 square. The unit digit is 8. So 8 into 8 gives you 64. And here the last digit is 4. We get the answer, right? And similarly for 292 square, the unit digit is 2. So 2 into 2 gives you 4. And this is the only and the last digit. Get the answer here also. And for 36 square, the unit digit is 6. So 6 into 6 gives you 36. And the last digit is 6, which is not leading you to the answer, right? So from where we are getting the answer? This is from 108 and 290 to the whole square, right? So this is the way to do this question. Moving to the next one. Given 125 square is 15625 and you need to find out the value of 126 square, okay? So we'll use the given term over here, that is 125 square is 15625. See, 125 square matlab this is 125 into 125. This is a given thing to you. Okay? Now see, 126 square. Can I write it as 125 plus 1 square? Can I write this as 125 plus 1 and 125 plus 1? No, you can write as this. Now we will use the normal way to multiply. That is, first term is multiplied with first term. 125 into 125 plus first term is multiplied with the second term. 125 into 1 plus 1 into 25. Second term is multiplied with the first term, and then second term is multiplied with the second term. 1 into. So what we get here, see, 125 into 125 is already given in the question. This is 15625. No need to multiply, right? 125 into 1 is 125. 1 into 125 is again 125. And 1 into 1 is 1. Right? So now add them. You will get 15625 plus 251. Now check out which option is suitable for this answer. This is the fourth option that is giving you the accurate result. Fine. Moving to the next question. Next question is, find the length of side of square whose area is 441 meters square. So area of square. Area of square. That is side into side. Right? Area is given 441 and side into side means side square. Right? If I need to find out the value of side, that means I will use the under root of 441. This will lead me to the answer. Okay? Side, find out side will under root 441. So we will use LCM method here. LCM method. And what is that? Find out the pairs. Okay? So let's do it. 441. 441 is 147 divided with 3 will get 49, divided with 7 will get 7, on 7 it will gives you 1. So 441 can be written as 3 into 3 into 7 into 7. we need to find out the under root of this. One thing I want to share is that a thing to remember is when you have square and under root together of any term, they will be cancelled to each other and it will lead to the single term. That means square and under root will be cancelled with each other. Okay. So here under root of 441. That means under root of 3 into 3 into 7 into 7, which is equals to under root of 3 square into 7 square, which is equals to under root of 3 square into under root of 7 square. Okay? Which is equals to 3 into 7. The answer will be 21. So side of square is equals to 21 meter. This is clear to you? Moving to the next question. You need to find the smallest square number that is divisible by each of the following number. The numbers are given as 4, 9 and 1. So we'll use again the LCM of 4, 9 and 0. Let's do it. 4, 9 and 10. So the LCM you will get 2 into 2 into 3 into 3 into 5. Things that you get here are these. Now see, the multiplication of this is 180, right? And see, there are pairs, but there is not a pair of 5. Make it a perfect square number. We will multiply this number by 5. That means we will multiply 180 by 5. When we multiply 180 by 5, we'll get 900. So 900 is the required smallest square number, which is divisible by 4, 9 and the way to find out the answer. Next question. You need to find out the smallest number by which 9408 must be multiplied the same way, right? We will use the LCM method over there also. This is 9408. 9408. So when it divided with 2, we get 4704. Then with 2, we get 2352. Then with 2, we get 1176, 588, 294, 147, 7, 3. 9408 can be written as, let's figure out how many pairs are there. 1, 2, 3 and 4. That means 3 is without pair. And the number by which we will multiply 9408 will be 3 only, right? So 9408 will be multiplied with 3. So what we get? 9408 when multiplied with 3, we will get 28224. Okay. Now they are asking to find out the square root of the product. So that means square root of 28224. That means square root of 2 the given this given prime factorization. बस इसमें हम 3 multiply कर देंगे, right? 2 into 2 into 3 into 3 into 7 into 7. Okay? So as they all are existing in pairs and we are taking the under root, so it will be 2 into 2 into 2 into 3 into 7 and we'll get the answer 252. So this way you will do this question. Moving to the next one, how many numbers are lying between the squares of the following numbers? As we have, I have already told you in the thing to remember, that is the numbers lying between the consecutive square numbers are 2n. So number lying between 16 square and 17 square. That means n square and n plus 1 square are 2n. So here n is 16. So the answer will be 32. Second, 99 square and 100 square. So it will be 2 into 99. So which is 190. Moving to the next question. So this is a pattern. This is actually question number 8. Pattern is given to you. See, let's find out it. The first is 1 square plus 2 square plus 2 square is equals to 3 square. The next one is 2 square plus 3 square plus 6 square is equal to 7 square. See how the things are getting, right? We are getting the third term by multiplying this. See, 2 into 3 is 6. Next step is 3 into 4 is 12. Yeah? It will lead us to the last fill up. So this is 9 into 10, which is 90 square. Square is already given, right? So some fill-ups we need to figure out. Now for the last term, see how we are getting the last term. It is obtained as 2 plus 2 minus 1, 6 plus 3 minus 2. Can you see that? 2 plus 2 minus 1 is 3. 6 plus 3 minus 2 is 7. Can you see that? Right? 6 plus 3 is 9. 9 minus 2 is 7. 12 plus 4 is 16. 16 minus 3 is 13. Right? 12 plus 4 minus that is 13. And similarly to answer the second last step, that is 4 square plus 5 square plus 20 square. So it will lead us 5 plus 20 is 25. 25 minus 4 is 21 square. And here also 90 plus 10 is 100. 100 minus 9 is 91. This is the answer of this question. Into the last one, question number 9. Question number 9, you need to find out the tiny squares in the following picture and write the prime factorization of the numbers of tiny squares. So here I can see that in every row and in every column there are 9 squares, 9 big squares. You see that 9 big squares in every row and every column, right? And the diamond shaped square, diamond shaped square is having 25 tiny squares. Can you see that? 25 tiny squares, right? Now we need to find out the tiny squares only, right? There are 41 diamond squares. 41, you can count it. Okay. So tiny squares are 9 into, so tiny squares are 41 into 25, which are 10, right? And can you see this grid? These one, I found that they are all having different number of tiny figures and they are not square in shape. Okay, so we are just using this one, and prime factorization of 1025 are, that is 5 into 5 into 41. That's all. Hope this video is helpful for you. Thank you very much. See you in the next video.